In this example, we're given the volume of a sample of gold, and we know its density, so from that we can figure out its mass. How? Well, we've got the equation, density equals mass divided by volume. That little thing that looks like a P is the Greek letter rho, and that's what's usually used to symbolize density. So density equals mass divided by volume. We've got two of the three variables in this problem, and if we have two of the three variables, we can figure out the third as long as we do some algebra first. What do we need the algebra for? We need the algebra to rearrange the equation. After all, what I've got is an equation that says density equals mass over volume. I need to solve for mass. So I need to rearrange this equation so that it says mass equals. So I've got to isolate that m so that it's by itself. How do I do that? Well, I got to get rid of that v that's underneath the m. In algebra, you learn that you can do anything you want to one side of the equation as long as you do exactly the same thing to the other side of the equation. So to get rid of v, what we'll do is multiply the right side of the equation by v. That will cancel v on the right side of the equation. However, to be consistent with the rules of algebra, we've also got to multiply the left-hand side of the equation by v as well. So when we do that, v cancels on the right-hand side of the equation, and it appears on the left-hand side of the equation, so I've got v times density equals mass. I'll just flip the equation around, I can do that in algebra, so that it now says mass equals density times volume. That's my equation I can use then to solve the rest of the problem. So I can just plug my numbers into the equation and get the answer, right? Not exactly. Look at the volume and density we were given. The volume is given in the units of liters, but the density is given with a unit of milliliters in it. Those units are inconsistent. This happens a lot in chemistry, and you're going to have to get used to looking for inconsistent units. I can't put both these numbers in the equation because the units won't work out properly. I've got to either change liters to milliliters or milliliters to liters in order to be able to use this equation, because I've got to have all my units consistent before I start putting numbers into the equation. It'll be easiest to convert the unit on volume, so that's what I'll do. I'll take liters and convert it to milliliters. I know the relationship between milliliters and liters. 1 milliliter is 0.001 liters. So now I can just do a standard conversion. I take my volume, 0.125 liters, I put it over 1 to make it a fraction, and then I multiply by 1. But the expression I use for 1 comes from the conversion relationship. I want liters to cancel, so it's going to go on the bottom of the fraction, leaving milliliters on top. So in the end, I've got 0.125 liters over 1 times 1 milliliter over 0.001 liters. The units on liter cancel, so in the end, I've got 125 milliliters. Now I can finally use my equation. My equation is mass equals density times volume. The density is 19.3 grams per milliliter. The volume is 125 milliliters. Notice now that the units are consistent, the unit milliliters cancels. It's on the bottom of the fraction in the first number, and it's on the top of the fraction in the second number. So in the end, milliliters cancel, and when I multiply the numbers out, I get 2412.5 grams. It's good that my unit is in grams because mass is in grams. So I've got the right unit. However, I don't quite have the right number, do I? The number isn't quite right yet because I haven't taken into account significant figures. We're multiplying here. So we use the multiplication rule for significant figures, and in that rule we count significant figures. So let's look at the two numbers we used to get this answer. We used 19.3. It has 3 significant figures. We also used 125. It has 3 significant figures. So we can report our answer to only 3 significant figures. So our answer isn't 2412.5 grams, it's 2,410 grams. That last zero isn't significant. It's at the end of the number, but it's not to the right of the decimal. So that zero isn't significant, so that number there, 2,410 grams, has 3 significant figures, and that's the proper answer.